Can I play Speckle?
Of course.
Hello.
H-E-L-L-O. Hello.
Meet Speckle, a very hungry seal looking to fill his belly with fish, all through the help of children practicing their spelling. Our international team consisted of Logan Metheny, Ziel, Nicole Rue, and Nguyen. Together we had a vision to help teachers and children in their spelling practices. Speckle brings fun to the application by collecting fish for each correctly spelled word. We kept up with solid team dynamics throughout the project, with regular stand-ups and check-ins to keep up to date on the progress of our app as well as everybody's personal mental health. Our planning process started out with just the main idea, where we planned to get the data from, and then it grew into something spectacular. We started with the name, and soon enough, Speckle showed himself to be a cute and hungry seal on the hunt for fish. We messed around with child-friendly color schemes and fonts to really make it interesting for kids to play, while still keeping the main theme of education. Throughout development, we frequently relied on our Figma board for design and on our Miro board for a detailed breakdown of the architecture of our application.
For our component architecture, we developed a model for our different routes and our varying React components for how our application would function. We also looked at what our general application's data structure would look like within our Redux global state management system. And finally found an API that would give us words as well as their audio files for how to pronounce them. Once we completed our initial wireframes, it was time to start building. For our initial steps, we went ahead and created our basic layout with an audio player and some basic letter inputs. For this step, we utilized mock data and spent the majority of our time learning how Redux worked, as well as how to implement it, since none of us had worked with it before. After we successfully completed our MVP, we were able to go ahead and start developing the layout to be a little bit more cohesive in line with our vision. It was at this time we connected the API as well as implemented a cleaner function to make sure we were only working with the data that was necessary for our application to increase performance and make it just generally easier to manage. We also implemented Redux Toolkit to allow us to simplify our Redux implementation by creating slices that would act as single stores for our state behavior, as well as automatically create things like action types, creators, and reducers.
We decided to take a stab at performance metrics in order to see how long it was taking for our app to process the data. We implemented performance.now to check the timing, and further researching how to up the metrics, we added an API catch set to a new map, which stashes away the result of the API call. Then our function is a gatekeeper, checking to see if the data is already in the catch, and it will save an API call by getting the already retrieved data. This is a way to reuse the information we have already received rather than having to retrieve it over and over again. This led us down the path of other ways we could optimize and enhance our application.
To further enhance our app, we took steps to make it feel more like a game. We added animation to our game page so that Speckle appears to move across the page. In addition, we added bubbles to both our start page and our results page. Once we had a working prototype, we did user testing to learn what could be improved for a user's gameplay experience. User feedback became invaluable to us when we added keyboard shortcuts. It helped to make note of what keyboard shortcuts a user expected would allow them to navigate throughout our app. We added autofocus so a user could immediately type without having to select the first box, as well as adding the ability to submit a response using the Enter key. Our app is responsive across screen sizes, so learners can practice spelling on the go. Finally, our site is fully tested using Cypress testing.
We then built our own backend to scale our app that will allow for user creation, class creation, and customization of data. We determined new user stories and asked ourselves questions like, which database structure would best suit our needs, SQL or NoSQL? How should we structure our data, the object that we would send? What endpoints will we need? What response should each endpoint give us back? How will we name our endpoints so they are RESTful? And what database should we use? As 4 front-end students forever curious about all things code, Speckle's MERN stack allowed our dev team to build a full-stack app in JavaScript as we made requests and received data from both a dictionary API and our own API, with next steps including a deployed backend to a cloud platform like Vercel or Heroku to get the server-side off localhost and the front-end off localhost so that actual teachers can start using them, and students, and everybody who wants to use Speckle.
As a team of 4 people passionate about how education and technology integrate, we're excited to explore 2-factor authentication, adding different levels of reading comprehension, optimizing the backend, larger database of words, and multiple languages going forward. Thank you for the opportunity to present our project.